next we will be looking into something called principle of duality. So, in case of in this what it says is that in case of Boolean algebra, the duality principle, so it says that you can interchange this and or operators, and at the same time you have to replace zeros by ones and ones by zeros, then you get the relations. For example, this is a Boolean expression a plus 1 equal to 1. So, we will see its proof later. So, then if this is true, then you can replace this 1 by 0 and this or by AND. So, this a dot 0 will be equal to 0. So, if a or 1 equal to 1, then a and 0 will be equal to 0. So, this is called the principle of duality. So, you can interchange the or and AND operator, and accordingly you have to interchange that ones and zeros. So, we will see them again and again. So, some of the properties of Boolean algebra. So, if you look into the basic theorems are like this. The first theorem is the properties of 0. It says that 0 plus a equal to a. So, if you have a variable a, then you can understand that if you OR it with 0, then the result will be equal to a. So, these are known as Boolean identities or Boolean theorems like that. Similarly, 0 and a equal to 0, then 1 plus a equal to 1, then 1 and a equal to 1. Okay. So, these are some of the properties of Boolean algebra. Then there is a commutative law, it says that a plus b, a or b equal to b or a. Similarly, so by means of duality, so you can replace this plus by dot. So, a dot b will be equal to b dot a. Then there is a associativity law, it says that a plus b plus c. So, that is I am doing OR of 3 variables, out of that I in the first case I do OR of a and b first, and then with the result I OR c. The second case I OR b plus c, b and c first, and then we do the OR of a with that. So, both the cases the result will be same. So, a plus b plus c is equal to a plus b plus c. Similarly, from the AND operation also, a and b and c is equal to a and b and c. So, so that is we can that is known as associativity law. Then there is a distributive law which says that a and b or c equal to a and b or a and c. And by means of duality, so if you replace these dots by or pluses and pluses by dots, okay, that is OR by and by OR. So, you get from this relation A, the relation B says that a plus b c will be equal to a plus b into a plus c. There is another distributive law which says that a plus a bar b equal to a plus b. So, you can get a proof of this very easily, say this one. So, this is actually a plus a bar b. So, if we allow if you look into say this rule, it says that I can write it as a plus a bar into a plus b by using the distributive law. Now, this a plus a bar, so this is equal to 1 because this is always true. So, a plus a bar into a plus b. So, this is a tautology. So, previously we have seen that p plus p bar is always equal to 1. So, that is tautology. So, this is equal to a plus b. So, a or a bar b is equal to a plus b. So, this way we can have a number of properties of this Boolean algebra. Then there is the idempotence or identity law, it says that a plus a equal to a and a equal to a. So, that is a variable plus itself. So, so x plus x in our normal arithmetic we have equal to 2x, but here it will be equal to x only. So, here a plus a equal to a. Similarly, a and a is equal to a. Then there is absorption law or redundancy law, it says that a plus a b equal to a, and by duality a dot a plus b equal to a. So, here also the same thing, like you can say, so if you try to analyze it logically, so it is a plus a b. So, a is true or a b is true. So, for this one also a has to be equal to true. So, naturally that is equal to a. So, this way we can have a number of rules for this Boolean algebra. Then this x plus x bar equal to 1. So, that is complementary law. So, that is the tautology. Then x bar equal to 0, that is the fallacy that we have seen previously. Then involution, involution says if you do complementation twice, x bar is the x dash is the complement of x, and then if you take complement again, then you will get back the original variable x. So, this is involution. And there is another pair of rules which are known as De Morgan's theorems. It says that x or y bar equal to x bar dot y bar. So, similarly by duality, so x y bar equal to x bar plus y bar. So, these are De Morgan's theorem. So, all these identities that we have written here, they are very much useful for the sake of Boolean simplification. Like if you want to get if you have a complex expression and you want to simplify, then you may use some of these rules to do the simplification process. Okay. So, we will be doing a few exercises before going further. Okay. So, let us look into some of the properties. That the first property that we will look into, it says that the complement of x is unique. The complement of x is unique. That means, we cannot have two different complements. Okay. So, complement of x means, so if x is a variable, its complement is x, we represent it as x dash, then it says that x, so we have seen that x dot x dash equal to 0 and x dot x plus x bar x plus x dash equal to 1. So, this is the complement. Then if I can for x, if I can find another variable x bar such that x and x bar is 0 and x plus x bar is equal to 1, or in general instead of writing x bar, to make it simple, suppose let us write it as y. So, y will be said to be complement of x. So, if I have got x dot y equal to 0 and x plus y equal to 1. Now, the question is, can I have more than one y for x? So, can I have more than one complement for x? So, if possible, let we have two complements, one is x1 and another one is called x1 and the other is called x2, are two complements of x, if possible. Complements of x if possible. Then what we can write? So, since x1 is a complement of x, so we have got this property x plus x1 equal to 1, x1 equal to 0. Similarly, since x2 is a complement of x, so we have got x plus x2 equal to 1 and x2 equal to 0. Okay. Now, x1 can be written as x1 into 1, x1 and 1. So, because that is there in the multiplication by the identity rule. So, that says that you can multiply, you can AND with 1. Now, this is so this can be written as x1, and now we have got this 1. So, I can write it, I can replace it by x plus x2. I can replace it by x plus x2. Now, if I so this is x1 x plus x1 x2. So, x1 so x1, so since x1 is a complement of x, so this is 0. So, this is 0 plus x1 x2. So, that is equal to, so it is 0 plus x1 x2. Now, this 0 can again be written as x x2 x x2 plus x1 x2 as we have. So, 0, since this x2 is a complement of x, x2, so x x2 is equal to 0. So, this 0 I am replacing by x x2. So, we have got x x2 plus x1 x2. So, this is so if you distribute, so you will get so this is x2 plus x1 x2. So if I take x2 common, if I take x2 common from these two, so I will get x plus x1, and x plus x1 is equal to 1. So I can say this is x2 into 1, and that is equal to x2. So it says that if I take two different if possible x1 and x2 are two complements of x, then we finally see that x1 and x2 they are same. So that proves that the complement of x must be unique. Okay. So next we will look into another property. So second property we will have, says that x plus 1 should be equal to 1. So how to do this? So to prove this, so x plus 1, it can be written as 1 into 1 and x plus 1. So this 1 can again be written as x plus x bar into x plus 1. So if you distribute, so this is x. So if you just multiply, so this is this x into x will give me x, then again this x into 1 will give me x, then this is x bar plus x. Okay. So this is what you are getting. So this is x. So these three x's, so that gives me x plus x bar. Okay. So if it is x plus x bar, so by that absorption law, you know that this is nothing but x plus x bar, and that is equal to 1. So we started with x plus 1 and finally we landed into 1. So this x plus 1 is equal to 1. So by duality, you can say that if you replace this plus by dot, that is or by and 1 by 0, so you can get the other property by duality. So x dot 0 equal to 0. So this is by duality. So you can also take as you can get a similar proof, but since we have proved the left one, so right one is not necessary. So we can get this one directly. Okay. So then we will prove that idempotent law. It says that x plus x equal to x. So for proving this, we start with x plus x. So this is equal to x plus x and 1. So this 1 can be written as x plus x bar. So this is and x plus x bar. Now if you so this is so x plus x is x into x plus so you can, if you do a multiplication, then you will get x plus x bar plus x plus x bar. So this x bars are equal to 0. So you finally get x plus 0. So that is equal to x. So you get the idempotent property proved, that is x plus x equal to x. And again by duality, so we can say that x dot x will also be equal to x by duality. So this proves the idempotent property. Next we will try to prove another result, which says that the involution property. So next we will prove the involution property, which says that x double complementation of x will give you back x complement and not of x, not of x. So that gives me x. So we do it like this, x not of not. So this can be written as x double not plus 0. So this 0 can be written as x bar or x dash. So if you do distribute, so you will get it like, so you will get it like something. So if you distribute this over this, so you will get this x bar plus x, as one term and this x bar bar plus x bar as the other term. So, we are distributing it. So, this is so this part. So, this part is equal to 1 because this is x bar plus x bar bar. So, it is x, if I write x bar equal to y. So, this is nothing but y plus y bar and y plus y bar equal to 1. So, this part becomes equal to 1. So, what we get is something like x plus x bar bar and 1. Okay. So, again we do a distribution. So, this part remains unaltered, x plus x bar bar. So, this part remains unaltered and this 1 we write it as x plus x bar. Okay. This 1 we write as x plus x bar. Then again we distribute. Okay. So, if we distribute this OR. Okay, so, this is since this OR distributes. So, we can write from there that this is equal to. So, or if you just do a flat multiplication, then you will get it like x plus x x bar plus x bar bar x plus x bar bar into x dash. Now, out of this, so this is 0, this is 0. So, you are finally getting like x plus x bar bar and x. Okay. So, this is so you will get it like this. So, this is x if you take common from here. So, you will get 1 plus x bar bar. Now, 1 plus anything is equal to 1. So, 1 plus y is equal to 1. So, this is equal to x. So, x bar bar is equal to x. So, this proves the involution property. Okay. So, you can now prove the other the absorption property. You can prove the absorption property, which says that x plus x y equal to x. Now, x plus x y equal to x can be proved easily, because x plus x y is equal to x dot 1 plus x y. So, that is if you take x common. So, we have already done this, it is 1 plus y. So, 1 plus y is equal to 1. So, that is equal to x dot 1. So, that is equal to x. So, x plus x y equal to x. So, if you follow the duality, then from here I can write that x dot x plus y. So, this will also be equal to x. So, this is the duality of the absorption law. Okay. Then prove another result. It says that x plus x bar y equal to x plus y. So, previously we have seen that x plus x y equal to x. Now, x plus x bar y equal to x plus y. So, x plus x bar y. So, this is so if you do a distribution. So, this is x plus x dash into x plus y by the distribution property. So, this is x plus x dash is 1. So, this 1 into x plus y. So, that is equal to x plus y. So, this way you can prove it, and again by duality you can say that x dot x bar x dot x dash plus y equal to x y. Okay. So, again the dot. So, that is by duality. Then associativity, if you want to show associativity, then we can do it like this. Associativity means, so associativity of or say OR operation. Associativity, suppose we have so we need to show that x plus y plus z equal to x plus y plus z. So, in Boolean algebra how will we show that? What we will do? So, this side we will call A, this side we will call B, and then we will bring this A and B to a similar form, and then we will show that they are same. How will you do that? So, say this is equal to x, this is equal to A. So, we will take x and A. So, this is equal to x into x plus x and x plus y plus z. So, this is equal to, by absorption law, this x into x. So, x into x plus y plus z. So, this is equal to x. Okay. So, you can if you want, so you can just do one more step and show that this is true. Like you can say, like, so if I do a multiplication, so this is x plus x into y plus z. So, this is x plus x y plus x z. So, x plus x y, so it is 1 plus y plus x z. So, that is again, so that is x plus x z. So, that is x into 1 plus z, that is equal to x. So, x a is equal to x. Okay. So, similarly, this x b, so if this is x a, then accordingly you can show that x b is also equal to x. So, this can be similarly it can be shown. Now, we take x bar a, so x dash a. So, x dash a is x dash into x plus y plus z. Okay, so, it is x dash x plus x dash into y plus x dash and y plus z. So, this is x dash is 0. So, this is 0 plus x dash and y plus z. So, this will give us, so this is x dash y plus z. So, x dash a gives me this thing. Similarly, you can say that x dash b so x dash b is it can be shown similarly that x dash b is equal to x dash into y plus z. Okay. So, you can just so you can show similarly that if you take x dash b, so then also it will lead to x dash into y plus z. So, if you can just do it once, like, so x dash b equal to x dash into x plus y plus z equal to x dash into x plus y plus x dash into z. So, this is x dash. So, x dash x plus x dash y plus x dash z. So, this x dash is, this is 0 plus x dash into y plus z. So, that is x dash into y plus z. So, we have got this x a, x b, x dash a and x dash b. So, we can say, so what is happening is that x a equal to x b equal to x. So, this is one observation. So, from here x a, x b, and another observation is that x dash a equal to x dash b equal to x dash into y plus z. Okay. So, with these observations, so we will be proceeding like this. Now, we have now we will take this the variable a. So, a can be written as a and 1. So, it is a into x plus x dash. So, this is equal to a x plus a x dash. Now, that a x is same as x a plus x dash a. Now, x a equal to x b and x dash a equal to x dash b. Right. So, I can take it can also be written as Bx plus Bx dash. If you take B common, so this is x plus x dash. So, that is B into 1, that is equal to B. So, we have got A equal to B. So, that proves our result that this OR is associative, the associativity of the OR is proved. So, you can use the duality. So, we have got x plus y plus z is equal to x plus y plus z. So, if you use duality, then it says that x dot y z will be equal to x dot y, it will be x dot y dot z. So, that way you can have the duality. Next, we will prove the De Morgan's theorem, the first law. So, the De Morgan's law so it says that x plus y bar or dash equal to x dash y dash. Okay. So, we have got these properties known to us, like x plus x bar equal to 1, then x bar equal to 0. So, these properties are known to us. Similarly, we can so what we do is that we take this sum. So, x plus y plus x bar y bar. Okay. So, if we do this, now we use the distributive property. So, this can be written as x plus y plus x dash into x plus y plus y dash. So, this is nothing but y plus, so this can be written as y plus x bar into x plus y bar. Now, this x plus x bar is equal to 1. So, I have got y plus 1 into x plus 1. So, that is equal to 1, fine. So, we have got this as equal to 1. Also, if I take this product, okay, so x plus y into x bar y bar. So, if I take this product, then what will happen? So, this can be rewritten as x dash y dash and x plus y. So, this is x dash y dash x plus x dash y dash y. So, x dash y dash x, so x and x dash will make it 0. So, it is 0 plus 0 equal to 0. Now, you compare these terms. So, this term x plus y and the term x dash y dash. So, what has happened? If I call it say p and let us call it q. So, from the first property, from this first proof, I can say that p plus q is equal to 1, and from this proof I can say that p q is equal to 0. That means, q is actually the invert of p, q is p dash. So, now if I substitute, so q is x dash y dash. So, x dash y dash is equal to p invert. So, p is x plus y, p is x plus y. So, x plus y dash. So, we have got this De Morgan's theorem here. Okay. So, x plus y dash equal to x dash y dash. So, this way we can prove the De Morgan's theorem first law, and by means of duality you can claim the second law, that is x y. So, if you replace this plus by dots, so you get the dual law. So, x plus y dash equal to x dash plus y dash. So, this is from here by means of duality. This is by duality. Okay. So, in this way, so we can have proof of these Boolean identities, and of course, the other way is to draw the truth table and show that these are all the two expressions are equivalent. So, that can be done, but if we want to show by Boolean identities, then also you can prove it like this fashion.